Can you hear me? Hello? Can you hear me now?
Yes, sir.
Yes, sir.
तो बीच में लाइट चली गई, फिर से वापस आ गई, इस बीच में ये कट गया कुछ. So, okay, in any case, let me start जहाँ हम थे. लाइट का क्या करें, भरोसा ही नहीं है. ऊपर से ये इस पे चलता नहीं हॉटस्पॉट पे अपना. अच्छा. Okay, anyways, तो हमने define किया था f is a function on an interval to r. F is uniformly continuous on this interval I if for any epsilon positive there exists a delta positive for all x1 x2 belonging to I such that fx1 minus f of x2 is less than epsilon whenever modulus of x1 minus x2 is less than delta. Or in other words, we can choose this delta for any epsilon independent of the point at which we are checking this condition. Anyway, तो फिर हमने दिखाया था, जैसे हमने दिखाया था कोई फंक्शन जो है continuous, मतलब पहले it's obvious कि अगर if f is uniformly continuous on I, अगर uniformly continuous है तो it implies that f, मुझे लिखना चाहिए, if f is uniformly continuous on an interval I on I, then it implies that f is continuous on I. Continuous on I का मतलब at each point of I, of this domain, of this interval. So एक चीज तो मतलब straight forward, क्योंकि अगर ये condition satisfy होती है, ये तो actually it's stricter condition than continuity, right? So the question is reverse is not true. जैसे हमने देखा f जो है it's a function from r to r. अगर मैंने कर लिया था f of x is equal to x square, of course it is continuous. It is continuous on r, जिसको मैं सोच सकता हूँ as an interval minus infinity infinity, but it is not uniformly continuous, जो हमने कल देखा. Continuous. So the question is, एक और एग्जांपल हम कर सकते हैं, जैसे इससे ज्यादा सिंपल एग्जांपल, बहुत सारी एग्जांपल्स है ऐसी फंक्शंस की जो कंटिन्यूअस है किसी इंटरवल पे लेकिन यूनिफॉर्मली कंटिन्यूअस नहीं है. जैसे ये f of x is equal to 1 by x जो है, अगर मैं लूं ऑन द इंटरवल 0 1 by 0 1, सिंपली इट्स अ सेमी ओपन इंटरवल. 0 पे इसको प्रॉब्लम है लेकिन उसको मैंने डोमेन से बाहर निकाल दिया. So this is continuous at each point of this because this is quotient of continuous functions and denominator is not 0. Therefore, f is indeed continuous on this interval I, this semi-open interval, a semi-closed interval, but it's not uniformly continuous. On this interval, because suppose मैं लूं epsilon equal to 1 by 2 and I choose my some delta positive, right, such that you know, I choose my x rather. फिर मैं ऐसे लेता हूँ, मैं लेता हूँ what I get is this, मैं लेता हूँ n bigger than 1 by delta and I take points 1 by n and I take, say, x1 equal to 1 by n, x2 equal to 1 by n plus 1. Of course, this belongs to the interval 0, 1 for all n. So in particular for this n, which is bigger than some positive number delta. So this interval may have, and furthermore, x1 माइनस x2 जो है वो किसके बराबर है? वो है बराबर 1 by n whatever n 1 by n minus 1 by n plus 1 वो होगा 1 by n into n plus 1 which is of course less than 1 by n because 1 by n plus 1 is less than 1 for all n and which is less than delta by my assumption because n is bigger than 1 by delta. So of course this is less than delta but कोई भी डेल्टा हो लेकिन अगर मैं लूं f of x1 minus f of x2 तो वो इनको उलट कर देगा फंक्शन वही करती है यानी वो होगा 1 by n minus 1 by n plus 1 that will be just equal to what n minus n plus 1 that is just equal to 1 which is clearly bigger than 1 by 2. Although x minus 1 by 2 is less than this positive number, but this is always bigger than 2. यानी it doesn't matter ये जो epsilon है, this ये जो delta है, फिर this depends upon n, है ना? यानी अगर मैं लेता हूँ मेरे point को, ये मेरा x1 है ना? x1 को लेता हूँ मैं less than this positive number, then this condition is violated. The condition for uniform continuity. So what I'm trying to say, the functions हैं जो uniformly continuous नहीं है, although they are continuous at each point of their domain of their interval. Now there's a theorem जो हमें इसके बारे में करना वो ये कि when does अगर हमें continuity है और when does it imply that the function is uniformly continuous? So let's do this theorem. कि a function which is continuous on a closed interval, let's call it AB, closed interval, यहाँ पे ध्यान रखना, interval पे ये जरूरी नहीं है, closed interval AB, then it is also uniformly continuous on this interval. In general ये जरूरी नहीं है कि अगर कोई फंक्शन जैसे कि हमने देखा एक दो एग्जांपल से कि कंटिन्यूअस फंक्शन यूनिफॉर्मली कंटिन्यूअस है, लेकिन अगर वो डोमेन जो है वो एक क्लोज्ड एंड बाउंडेड इंटरवल है, then it is also uniformly continuous on that interval. So let's do the proof. So let f be continuous on this interval. On this interval I, जो कि है closed bounded interval, and suppose that f is not uniformly continuous on it. हम contradiction से prove करेंगे. Then for any epsilon positive, there must exist some delta positive such that f of x minus f of y must be greater than उस condition को violate करना चाहिए whenever x minus y is less than delta. And there should be some delta positive for any epsilon positive. In particular, right? Okay, मैंने क्या लिखा? नहीं, for any, नहीं मैंने उल्टा लिखा यहाँ पे. For any epsilon positive नहीं होना चाहिए. It should be अब कोई भी epsilon लो, there should be some delta which violates it. यानी there should exist some epsilon positive such that for any delta positive, this is true. In particular, I can say, in particular, कोई भी डेल्टा हो सकता है. For delta equal to 1 by n, we get where n is a natural number, क्योंकि कोई भी positive number हो सकता है. We have, there exists an epsilon positive such that f of x minus f of y is greater than equal to epsilon for all x minus y less than 1 by n. So this means all intervals that are arbitrarily close, points that are arbitrarily close together. So that would mean what? यानी अगर x minus y less than 1 है तब भी ये true है. अगर x minus y less than 1 by 2 है तब भी इनके जो difference है कम नहीं हो रही है. It is bigger than equal to epsilon. अगर मैं इससे भी छोटा कर दूं x and 1 तब भी ये epsilon से बड़ी है, ये कम नहीं हो रही है distance. So मतलब इस तरह से situation. So in that manner, I can find a sequence. तो अगर मुझे इन axes के लिए है, तो I can call them कि I can find sequences x and y n. यानी मैं इसका नाम दूंगा जब भी कोई इसको satisfy करेगा condition को, इसका नाम मैं करूंगा x1 minus y1. यानी वो x's and y's which are less than 1. इसी तरह से इसका नाम मैं दूंगा x2 y2. इसका नाम मैं दे सकता हूँ x3 y3. In this case, I can find two sequences. Because of this bound, which is in terms of natural numbers. So that means we can find real numbers xn, yn such that f of xn minus f of yn is bigger than equal to some epsilon for all xn minus yn less than 1 by n. In this way, we have found two sequences. So in this way, so we have found two sequences xn and runs from 1 to infinity and yn and runs from 1 to infinity, which are contained in the domain, of course, contained in I equal to AB such that modulus of f of xn minus f of yn is bigger than equal to epsilon for all n belonging to the set of natural numbers. ठीक है? क्योंकि हम एक sequences ऐसी ढूंढ सकते हैं, so that this is true. Now, since these sequences are contained inside this interval AB, यानी ये जो मेरी sequences हैं, they should also satisfy this thing, yn or ये मैं लिखूंगा नहीं, but that's obvious. They are contained in this interval. Now, what we do is that the sequences xn and yn n runs from 1 to infinity and runs from 1 to infinity are inside this interval AB and are therefore bounded. Therefore, by Bolzano-Weierstrass theorem, they must have a limit point. Theorem, each has at least one limit point. Suppose the zeta is the limit point of the sequence xn and eta is the limit point. लिखना चाहिए क्योंकि एक से ज़्यादा भी हो सकता है, ज़रूरी है कन्वर्ज कर रही है. Limit point of yn runs from 1 to infinity, right? Then since AB is closed, पहली बात तो ये कि closed subset है, so it contains all its limit points. तो ये इसका limit point है, मतलब और ये इसके अंदर रहती है, तो फिर वो इसका भी limit point है. So it implies that ये जो zeta and eta है, they must belong to this interval in the domain, and there exist subsequences. क्योंकि limit point अगर किसी sequence की है, तो you can always find a subsequence that converges to that point. So there exists a subsequence, let's call that xn sub k. K runs from 1 to infinity, and y sub n sub k, k runs from 1 to infinity, of xn, n runs from 1 to infinity, and y sub n, n runs from 1 to infinity, respectively, such that x n sub k converges to zeta and y n sub k converges to eta as k approaches infinity. Right? Also, मैं इसका नाम 1 दूं, जो मेरा इक्वेशन, ये इसको अगर हम 1 मान लें, मैं इसको 1 मान दें. इसी का सबसेट एक है जो सब सीक्वेंस, अगर ये कंडीशन सीक्वेंस के लिए ट्रू है तो सब सीक्वेंस के लिए भी ट्रू होगी, क्योंकि वो उसी का सबसेट है. So also I should have such a by 1, I should have what, f of x n sub k minus f of y n sub k is greater than or equal to epsilon when x n sub k minus y n sub k is less than 1 by n sub k. Okay, now this is true for all nk belonging to the set of natural numbers. Okay, but we know that nk is always greater than or equal to k, so it means that 1 by nk is less than or equal to 1 by k. This is less than 1 by k. यहाँ पे लिखते हैं, चलो. So we have x n sub k minus y n sub k is less than 1 by k for all nk belonging to जो भी इसका indices है. It implies that, of course, it's rather easy. वो क्या कि x n k minus y n k जो है, it must converge to 0 as k becomes very very large. अगर वैसे नहीं तुम कर सकते तो तुम ऐसे करो squeeze principle. तो इसका मतलब ये है, इसका मतलब ये है. So then apply the squeeze on both sides. This converges to 0, this converges to 0, and they lie between them. It implies that limit x n sub k, limit x n sub k minus y n sub k is equal to 0 as k goes to infinity, which implies that limit k approaches infinity, x n sub k, like the rules of limits, y n sub k is equal to 0, which implies that this is eta minus zeta minus eta is equal to 0, which implies that then the zeta must be equal to eta. यानी ये जो है दोनों का लिमिट पॉइंट सेम होना चाहिए, दोनों का जो सीक्वेंसेस का लिमिट, सब सीक्वेंसेस का लिमिट सेम होना चाहिए. So it implies that also क्योंकि हमने माना है f is continuous, that is given. अगर continuous है, so therefore limit k approaches infinity, f of x n k must be equal to, it should converge to f of the limit k approaches infinity x n k, that is equal to f of zeta, and similarly limit k approaches infinity, f of